All right, so let's go over the last few questions on the homework. This is number 16. So it says, consider the following shaded region, and then it shows you this, right? So what we have to do in all of these shaded region questions is take the integral of the top function minus the bottom function. So the top function is, it says a is 6, so this is 6 times x minus x squared. And then I take away the bottom function, and b is 4, so this is minus 4x. Okay, so I'll leave it to you to set this up. I mean, obviously you can take 4x away from 6x, right? So there's this question about what the limits should be, and you can tell just from the picture that one of those limits is probably 0. And you don't have to trust the picture. What you should do is set these two things equal to each other and solve. So you should set up the equation 6x minus x squared is equal to 4x. And the solutions of this equation will tell you what the intersection points are. So let's see if we can make it a little bit more nice. So take 4x away from both sides and you get 2x minus x squared is equal to 0. And you can factor out an x, right? And then you get 2 minus x equals 0. Okay, so you're supposed to integrate from here to here. So those are the limits. And it should be pretty obvious now what you're supposed to do. So let's go on to number 17. So it's another shaded region problem. Okay, so frequently they throw in these where it's more convenient to integrate with respect to y than it is to integrate with respect to x. So how can you tell when that's true? So notice that if I were going to integrate this with respect to x, it would be kind of hard because here I am going to have this function on the bottom, this function on the top. So, if I were to solve for x for this red curve, which I guess is given by this equation, if I were to solve for x there would be two functions. I'm sorry, if I were to solve for y, there would be two functions corresponding to plus and minus that you get when you take the square root. So I would need to do, this part, and then I would need to do this part, and then this other part, and so I would have to set up 3 different and fairly complicated integrals, okay? But it's easier if you do it with respect to y, because look, if you turn your head 90 degrees to the right, then the blue curve is always on top, and the red curve is always on the bottom, so you can set up that. So the blue curve seems to be 3y minus y squared, okay, so that's the top curve. And we can take away the bottom curve, which is y squared minus 8y, and remember it's quantity minus, so this becomes plus. And I need more parentheses, and you have a dy, and now you're good to go. You need to put in the limits, but I think you'll be able to tell what the limits are, right? Actually, it's not that. This is going to be one limit, and this is going to be another limit. And so you'll just have to figure out what the, no, sorry, that's completely wrong, isn't it? No, you integrate from right here on the y-axis to right here on the y-axis. And they're just telling you what those numbers are, so that's really easy. And let's go to 18. So this time we have to sketch the region enclosed by the given curves. Alright, so I don't see any curves. I think they've probably just been deleted by this stupid program. So let's look back at the original assignment and see what they are. Okay, so it's giving us, this is a line, 2x plus 1, and then there's another line. So what you should do if you don't know how to graph these things is go to some kind of graphing website. Like, I like to use foodplot, but it doesn't work with Internet Explorer. So if you only have Internet Explorer, then maybe you want to use another website like Wolfram Alpha. So one line is 2x plus 1, so let me type that in here. 2 times x plus 1, that gives me the curve. And the other thing is 10 minus y squared. So 10 minus x squared. I don't know why I say what I say, but that's what it is. And okay, so the other thing is x equals minus 1 and x equals 2. So what those are going to be are vertical lines. There's a vertical line at minus 1 and a vertical line at 2. So you'll just have to imagine that those are there. So let's zoom out a little bit. And actually I can make those be there if you'll just bear with me and not ask questions about where this is coming from. So there's a vertical line at -1, and I can put in a vertical line at +2 also, like this. So x minus 2, okay. And now let me reset, and I can maybe pan around a little bit here. So what I'm looking at now is the region enclosed by the red curve on top and the black line on the bottom, and we're going between the blue line and the red line. And so we're just integrating from -1 to +2 of the top curve minus the bottom curve. And the graph makes it very clear which is on top and which is on the bottom. All right, so let's go back to this thing. And we're on the next one now, number 19, but again, that information has been lost, so let's go back to the homework. So in number 19, it says, sketch the region enclosed by the curves, describe blah, 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 blah. So it's just exactly like that one I just did. And if you can't graph these, I mean, it's coming to the close of the time in your life that there was ever any point in you knowing how to do that, but it will still be very useful for the next few months. I'm assuming that you're not going to take any math after Calculus 2, but hopefully you will, so who knows. Number 20, sketch the region enclosed by the given curves. Okay, it's exactly the same, and it's exactly the same. So, okay, I hope that helps, and I will stop this video.